we've learned about how to add vectors and to find their magnitude and direction. The next thing we need to learn about is how to multiply vectors. And we're going to learn two different methods. Today's method is the dot product, which is also called the scalar product because we get a scalar out of it. And if you need a reminder, a scalar is just a number. It can have a magnitude as well, and in this case it will when we use it. Okay, so the dot product is a way to work with vectors, but first we need to set up our vectors, so we'll do a little bit of practice first. So I'm going to do a vector, let's see, 1, 2, 3, 4, 1, 2, 3, there we go. We're going to do one vector, which is vector A, which is given by 4 in the I hat plus 2 in the j hat. Another way to write these vectors, by the way, is to just write them by their components. In other words, as 4, 2. Okay, that's another shorthand for writing these that you'll sometimes see. And vector B, I'm going to make 1 in the I hat direction plus 3 in the j hat direction. I guess I should have labeled this X and Y. So B is going to be 1 unit this way and 1, 2, 3 units this way. So it's going to look like that. So that's B and that's A. And B, of course, will be given by 1, 3. Okay, so what I want to do before we get into this dot product or scalar product is I actually want us to practice one more time, just very quickly, getting magnitude and direction. So for A, the magnitude is just going to be the Pythagorean theorem relationship, right? So that's going to be 4 squared plus 2 squared. Take the square root of that. So 4 squared is 16. So that's square root of 16 plus 4, or the square root of 20. And then I need to look up what that is, and that's 4.47 units. And then the angle, which would be here for A, we're going to look at doing SOHCAHTOA. Now we do have the hypotenuse, but in general, because this is 2 and this is 4, we're going to write this as the inverse tan, arctan, of then opposite 2 over 4, or of 1/2. And so when I do that, I get an angle of 26.6 degrees. So this is a way for you to double check that your calculator is in degrees and not radians, and fix it if it's not. Okay. B, we do the same thing. Square root of 1 squared plus 3 squared gives us square root of 10, 1 plus 9, which is 3.16. And then theta for B, we use the same thing. Tangent, arctangent of, in this case, I've got, that's my theta B right there, the green one that I just drew in, and so that's a 3, which is the opposite side, over a 1. So 3 over 1, and arctangent of 3 gives me now 71.6 degrees, which looks pretty good here. This one looks fairly big, 71 degrees seems reasonable, and A seems reasonable at 27 or so degrees. Okay, so I haven't done anything new at this point. So here's where we're going to learn about the multiplication. So multiplying, so the dot product or the scalar product of A dot B means we don't FOIL it, we multiply like terms. So the I hat terms get multiplied together, so 4 times 1, and then we add the multiplication of the j hat terms. We don't do any cross terms. So plus 2 times 3. And all the vectors go away because this is a scalar. We just get a number afterwards. And so this gives us 4 plus 6, which is 10. Okay, now why is it defined this way? It turns out that it's defined this way because it's useful. You can define a multiplication sort of any way you want as long as you specify the rules and make sure it uses rules of multiplication. And in this case, it turns out that A dot B is equal to the magnitude of A times the magnitude of B times the cosine of the angle between the two vectors. So that would be this angle right here. That's phi. And so we can just check this by saying, what's the magnitude of A? Well, the magnitude of A is this, or square root of 20. Magnitude of B is square root of 10. Cosine of the angle, we're going to have cosine of, and the angle that we have, well, this angle B right here is 71 degrees, so we have 71 degrees as the first angle, and the other angle is 26, or 71.6, so we would have 71.6 minus 26.6 degrees would be this blue angle right in here. Okay, so once we have that, we go ahead and do this subtraction, and that gives us, well, the 6's cancel, 5, 6, 45 degrees. Okay, so that works out nicely. And so if we plug all of these into the calculator, so this is now square root of 200 times cosine of 45, which is square root of 2 over 2, as it turns out. So that turns out to give us a 10, just like we got before, the whole thing, all of this together. So these are the same values. So it turns out that this is a way to get how much one vector is lined up with another. Let me give you an example, another example. I'll just go off to the side just a little bit. Suppose we have vector C, which is given by 5 in the I hat plus 0 in the j hat. Right? So vector C looks like this. Then if we do A dot C, what we have is 5 times 4 in the I hat direction plus 2 times 0, which is, of course, 2 times 0 is 0, so this gives me a 20. And if I look at the magnitude of if I do it by saying A dot C is equal to the magnitude of A times the magnitude of C times the cosine of the angle between them, well, now we're looking at A, magnitude of A is 4.47, or the square root of 20. The magnitude of C, that's easy, it's 5, right? Because it doesn't have anything in the, there's C. It doesn't have anything in the y direction. And so if we look at this, then we have A times C. So let me rewrite C just a little lower so you can see it. And then the cosine of the angle between them is just going to be the red angle, right? Because that's how much A is up from C. So times cosine of 26.6 degrees. And if we multiply that all together, we get 20 again. So this tells us sort of the size of A, how much A's projection, or AX, right here, times C is. Okay, and this turns out to be quite useful in physics, and so that's one of the reasons why it's this multiplication is defined this way.